Taylor series and Meclaurin series. Okay. Okay, don't worry. We'll take later. Okay. So actually, as we know that, so the series expansions of some functions, as you know, e power x. So what is the expansion of e power x? Anyone? What is the expansion of e power x? Anyone? Are you hearing my voice? What is the expansion of e power x?
One plus x
1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus and so on, right?
2 factorial plus.
Okay, fine. At least someone responded. So you know the expansion of sin x. Expansion of sin x is x cube by 3 factorial, x power 5 by 5 factorial. Okay, now. Similarly for cos x, 1 plus x square by 2 factorial, sorry, minus x power 4 by 4 factorial plus minus. So, okay, now. Okay, now. So these are the some expansions of some functions. Likewise, you know, maybe e power minus x tan x ln of 1 plus x. Okay, so these are all. How these are all comes a function into sum of infinite terms. Okay, sum of infinite terms. Okay, the function can be expressed. Okay, any function, whatever it is. Okay, how it comes. That's what today's class we are going to be discussing. That sum of infinite terms. Okay, a function can be expressed into sum of infinite terms. Means a function in series. The function is converted into series form. A function is converted into e power x. How it will be converted? How it will be converted? X equal to 0 to infinity x power n by n factorial, right? So this is a series. So this is a series, right? So how a function converting into, okay, converting into a series form. Okay, so not only e power x sin x, whatever like x square plus 3x 1 by x plus 1 by x plus 1 by x, whatever the function when we take, how it will be converting into, okay, a series expansion, the sum of infinite terms. So that's what today's class, that will be nothing but power series. That will be nothing but power series. Okay, power series. Okay, so our Taylor series are nothing but Taylor series. Okay, and which is nothing but suppose the Taylor series of any function f of x, the Taylor series of f of x at any point of x equal to a, at x equal to a is the Taylor series of x equal to a. Okay, the Taylor series of f of x at x equal to a is, okay, or the Taylor series in terms of x minus a, or the Taylor series of okay, in terms of x minus a, in terms of x minus a. Okay, or the Taylor series of whatever you call. Okay, the Taylor series of, okay, about x equal to a, about x equal to a, whatever you call. Okay, whatever you call. Okay, is called, is nothing but, okay, is nothing but, okay. So f of x can be written as f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole power 3 plus and so on, plus and so on, plus and so on. Okay, na? So where nothing but, which is nothing but sum of n equal to 0 to infinity f power n of a by n factorial into x minus a whole power n. F power n of a by n factorial into x minus a whole power n. So that is the series expansion of f of x. Okay, the series expansion of f of x. Okay, so let us assuming this as an. Let us assuming this as an. Okay, it means that this will nothing but summation n equal to 0 to infinity an into x minus a whole power n. An into x minus a whole power n. Okay, na? Okay, na? So, uh, so this is the Taylor series expansion of f of x. Okay, summation n equal to 0 to infinity an into x minus a whole power n. Okay, with positive radius, with positive radius of convergence, with positive radius of convergence, and converges to with positive radius of converges and converges to okay or where a and an equal to an equal to nothing but f power n of a by n factorial, f power n of a by n factorial. Okay, na? So that is the Taylor series expansion, okay, of any function about x equal to a or in terms of x minus. Okay. So suppose if I take up to this part, suppose I will take f of x as f of a, okay, plus f dash of a by 1 factorial into x minus a. So this is the linear polynomial. This is the linear polynomial. Okay, now suppose if I take up to 2 f double dash of a by 2 factorial into x minus f dash of a by 1 factorial into okay, na? This is f dash of a by f of x equal to f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square. So this is called quadratic polynomial. Quadratic polynomial. Okay. Or polynomial of order 2. Or polynomial of order 2. Polynomial of order 2. Okay. So similarly, if I take f of x as f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube. So this is called cubic polynomial. This is called cubic polynomial or polynomial of order 3 or degree 3. Polynomial of order 3. Okay. So similarly and so on, f of x can be written as f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus and so on f power n of a by n factorial into x minus a whole power n factorial into x minus a whole power n. Okay, this is called the polynomial of degree order n. Polynomial of order n. This is called the polynomial of order n. Okay, na? Okay, na? Anyone having doubts, please? Anyone having doubts? So that is the formula to expanding any Taylor series. Okay, na? If they ask up to order 1, you should write order 1. If they want, okay, order n, you should write order n. Okay, na? So write down example. So find the Taylor series of find the Taylor series of order 1 of f of x equal to ln x at a equal to 1. At a equal to 1. at A equal to 1. So what is the Taylor series of order 1? The Taylor series of order 1 is f of x equal to f of a plus f dash of a by 1 factorial into x minus. So what is a here? So f of x is ln x. F of a is ln 1 0. F dash of x is 1 by x. F dash of 1 is 1 by 1. So therefore f of x is 0 plus 1 by 1 factorial into x minus 1. So this is nothing but x minus 1. Okay na? So left side enti ln x equal to x minus 1. For how it will be equal, sir? Nanakandi. For order 1 it will be equal. Okay na? How it will be equal, sir? Anakandi. For order 1 it will be equal. Okay na? Okay na? Next. రాసుకున్నారా? రాసుకున్నారా? So find the Taylor series of one by x at x equal to at a equal to 2 of order 2 of order 2 of f of x of f of x. So the Taylor series of order 2 is f of x equal to f of a f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square. Okay na? So given f of x is 1 by x, a equal to 2. So f of a equal to 1 by 2. So what is f dash of x? Anyone? What is f dash of x? Anyone?
Minus 1 by x square.
Minus 1 by x square. What is f dash of 2? What is f double dash of x? Anyone?
2 by x cube.
అంటావా నువ్వు వచ్చేస్తున్నాడు చెప్పదు.
Okay na? So therefore the Taylor series is f of x equal to f of a 1 by 2. F dash of a minus 1 by 4 by 1 factorial into x minus 2. F double dash of a is 1 by 4 by 2 factorial into x minus 2 whole square. Okay na? Okay na? So find the Taylor series of f of x equal to e power minus x of order 3 at x equal to 0. Find the Taylor series of f of x equal to e power minus x at x equal to 0 of order 3. Anyone? So The Taylor series of order 3 f of x equal to f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube. So what is f of x? We have e power minus x equal to 0. F of 0, e power 0, 1. F dash of x, what is f dash of x? Anyone?
Minus e power of minus.
F dash of 0 minus. F double dash of x,
E power of minus 6.
F triple dash of x,
Minus e power of minus 6.
okay. So replace Andy, therefore f of x equal to 1 plus minus 1 by 1 factorial into x minus 0 plus 1 by 2 factorial into x minus 0 whole square minus 1 by 3 factorial into x minus 0 whole cube. Is it correct? So nothing but what it is 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial. Is it correct? Anyone? Anyone having doubts? సో ఆర్డర్ మెన్షన్ చేయకపోతే అప్ టు ఎంత ఆర్డర్ చేయాలి అప్ టు ఎంత ఆర్డర్ కూడా చేయక్కర్లేదు కొన్ని టర్మ్స్ చేసి అండ్ సో అని రాయడం మీకు నచ్చినంత వరకు చేసి ఒక 3-4 టర్మ్స్ చేసి అండ్ సో అని రాయడం ఆర్డర్ మెన్షన్ చేయకపోతే given f of x equal to sin x a equal to pi by 4 f of a equal to the sin pi by 4 f dash of x derivative of sin x is cos x f dash of pi by 4 f double dash of x f triple dash of x f fourth dash of x minus of minus plus sin x. So replace this therefore the Taylor's polynomial f of x equal to f of a plus f dash of a by 1 factor into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus and so on. This is nothing but 1 by root 2 plus 1 by root 2 by 1 factorial into x minus pi by 4 plus f double dash of a minus 1 by root 2 by 2 factorial into x minus pi by 4 whole square plus 1 by root minus 1 by root 2 by 3 factorial into x minus pi by 4 whole cube plus 1 by root 2 by 4 factorial into x minus pi by 4 whole power 4 plus and so on. And so on. Any doubts, please? Is it correct? Any doubts, please? So likewise, you can find the Taylor series at any point of x equal to a. At any point of x equal to a. Okay na? So manaku general ga sin x, cos x ivi telusu. Okay na? So nothing but x equal to 0 at x equal to 0. Now you can able to find x equal to pi by 4, x equal to pi by 3, x equal to pi by 6, x equal to pi, x equal to minus pi, whatever you like, okay. For all the values you can able to find, okay. For all the values, not only this, now the computers are came, so whatever the value 0.01 is equal to 0.1 radians, all you can find, okay. ఏది కావాలో అది కనుక్కోవచ్చమ్మా ఇప్పుడు మన కంప్యూటర్ యుగంలో. ఆర్ యు హియర్ మై వాయిస్? Yes, please. So similarly, the Taylor series about x equal to 0, the Taylor series about x equal to 0 is nothing but what? F of x is nothing but what? F of 0 plus f dash of 0 by 1 factorial into x minus 0 plus f double dash of 0 by 2 factorial into x minus 0 whole square. Okay na? Plus f triple dash of 0 by 3 factorial into x minus 0 whole cube plus and so on. Okay na? Which is nothing but f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus f triple dash of 0 by 3 factorial into x cube plus and so on. Okay na? Similarly, nth term will be take f power n of 0 by n factorial into x power n plus and so on. Okay na? So this is called the Taylor series about x equal to 0, which is called Meclaurins series. Meclaurins series. The Taylor series about x equal to 0 is called as Meclaurins series. Okay na? Meclaurins series. Okay na? So find the Meclaurins series of f of x equal to 1 by 1 plus x. Okay. So there is no about x equal to 0 like that here because of Meclaurins series is nothing but x equal to 0. Meclaurins series is nothing but x equal to 0. అర్థమవుతుందమ్మా? So given f of x, what is given f of x? 1 by 1 plus x. So f of 0, what is f of 0? So what is the derivative of f of x? Anyone? What is the derivative of 1 by 1 plus x? Anyone?
Minus 1 by 1 plus x whole square, sir.
Okay. Very good. Minus 1 by 1 plus x whole square. Okay na? So what is f dash of 0? Minus 1. What is f double dash of x? 2 by 1 plus x whole cube. F triple dash of x? Minus 6 by 1 plus x whole cube. F triple dash of 0? Minus 6. And so on. So therefore, the Meclaurins series of f of x is so what is that Meclaurins series? F of x equal to f of 0 plus f dash of 0 by 1 factor into x minus x plus f double dash of 0 by 2 factor into x square plus f triple dash of 0 by 3 factor into x cube plus and so on. So what is f of 0? 1. What is f dash of 0? Minus 1. What is f double dash of 0? 2. This is minus 6. So all gets cancelled, right? This is nothing but for 1 by 1 plus x. అదే కదా మనం డెరివేటివ్ డిఫరెన్షియల్ ఈక్వేషన్ లో పిఐ కనుక్కునేటప్పుడు చేసామమ్మా. పిఐ కనుక్కునేటప్పుడు 1 minus x plus x square minus x cube సో అదే 1 plus both are minus 1 minus x whole inverse 1 minus x whole inverse ఏమొస్తుంది? 1 minus x whole inverse చేస్తే ఏమొస్తుంది? 1 minus x whole inverse చేస్తే ఏమొస్తుంది? ఓకేనా? మనకు డిఫరెన్షియల్ ఈక్వేషన్ లో పిఐ కనుక్కునేటప్పుడు చెప్పాను మెథడ్ 3 కి, గుర్తుందా? సో దిస్ ద ఎక్స్పాన్షన్. హౌ ఇట్ కమ్స్ ఈస్ లైక్ దిస్. సో ద ప్రూఫ్ ఈస్ లైక్ దిస్. ఓకేనా? ఓకేనా? Now the thing is, okay. So the Taylor series or Meclaurin series. So Taylor series తీసుకుందాం. Taylor series. Please listen now. So f of x at x equal to a, the Taylor series of f of x at x equal to a, the f of x will be f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus f triple dash of a by 3 factorial into x minus a whole cube plus and so on f power n of a by n factorial into x minus a whole power n. Okay na? Plus next term ఏమవుతుంది? f power n plus 1 of a by n plus 1 factorial into x minus a whole power n plus 1. Okay na? Whole power n plus 1. Okay na? Plus and so on. Suppose we consider the Taylor series or Taylor's polynomial of degree n, the Taylor's polynomial of degree n, that will be up to this. Okay na? That will be up to this, right? So the remaining all the terms, the sum of remaining all the terms is called as a remainder. Sum of remaining all the terms, okay, is called as remainder. Okay na? So we can estimate this remainder, means that we're treating that the series expansion of any f of x taking by up to nth term is okay. Up to nth term is finite. Okay, is okay. So no need to go for that much. That will be satisfying to us. Okay. So whatever above terms of after n, all we treating that having very less quantity, means we are treating that these are all having the sum of all these are having a very less quantity like 0.01, 0.001, 0.0001. Okay, likewise, it's assuming that we are treating that, assuming that, okay, it's a very less quantity. That's why we are neglecting that term. Okay, we are neglecting that term. Okay, all these terms. We are neglecting of all these terms. Okay, now, and that whatever the neglecting all these terms, we called as a remainder. All this called as remainder. We can estimate this remainder. Using of a formula. I call this as Rn of x. Which is nothing but maximum of okay, modulus of using of this n plus 1th derivative. Using of this n plus 1th derivative. N plus 1 factorial. Okay, x minus a whole power n plus. And assuming that n plus 1th derivative of any function at any point of a cannot be exceeding of some constant m. Assuming that n plus 1 derivative of any f at point of a, okay, it's maximum of capital M, not exceeding of capital M. Okay, maximum value of this is capital M. Then this will be Rn of x will be less than or equal to m by n plus 1 factorial into modulus of x minus a whole power n plus. So using this formula, we can estimate the remainder, or we can find how many terms are needed that the remainder will be very negligible. The remainder will be negligible, means like it will be 0.1 or 0.01 or like 0.001 likewise. 0.001 likewise. Okay na? Okay na? Right? Anyone having doubts, please? So that is the formula to estimating the remainder. remainder. Okay na? So write down a problem here. Okay. So estimate the remainder of f of x equal to e power x. Write down the problem here. Estimate the remainder. Estimate the remainder of f of x equal to e power x at x equal to 1, and the remainder will be, and the remainder is within 0.1. The remainder will be within 0.1. Okay. Okay, no problem. Estimate the remainder cheddam. Okay. Estimate the remainder cheddam. Okay. Okay. And okay. Sorry, ఇక్కడ రాసుకోండి. and పెట్టి రాసుకున్నాము. And find the number of terms required. Find the number of terms required. Number of terms required. Number of terms. Find the number of terms required. Okay. Required. Okay. Required. The remainder will be within 0.0, within 0.1, within 0.1. Okay na? Yeah. ఇక్కడ అట్రా అయ్యకుండా ఇక్కడ between 0 and 1 అని రాసుకుంది. Between 0 and 1. ఓకేనా? సో చూడండి. సో f of x is e power x. F of x is e power x. And f dash of x is what? F dash of x is what? E power x. F double dash of x is what? E power x. And so on. F power n of x is what? That is also e power x. That is also e power x. Okay. So the remainder will be, I'll go for next slide. I'll go for next. The remainder will be Rn of x is less than or equal to capital M by n plus 1 factorial into mod x minus a whole power n plus 1. Okay na? Whole power n plus 1. Okay na? So what is M? What is M? The n plus 1th derivative maximum value of, okay, between the point, at the point. Okay na? At the point. Okay na? So f power n plus 1th derivative, what? F power n plus 1, this is nothing but f power n plus 1 of 1. Okay, f power n plus 1 of 1 is what? F power n plus 1 of what? F power n plus 1 of x into f power n plus 1 of x into e power x derivative is e power x. E power x derivative is e power x. Okay na? Mod e power 1. Mod e power 1. So mod e power 1 value enti? That nothing but e. E is nothing but e value entama 2 point. What is the value of e? Anyone? Nothing
7.
but yeah, 2.73. 2.732 like that, right? It's nothing but maximum of 3. Maximum of 3. Okay na? You can take 2.7 also, not a problem. Okay na? Maximum of, okay na? But I am assuming that it will be maximum of capital M, M I treating as 3. So then what is Rn now? What is Rn of x? Less than or equal to, is less than or equal to 3 by n plus 1 factorial. Okay, 3 by n plus 1 factorial mod 1 minus 0 whole power n plus 1. Nothing but 3 by n plus 1 factor. 3 by n plus 1 factor. Okay na? Okay na? So manakem kavali? The remainder will be, so between of 0.1 అయితే n value ఎంత కావాలి? n value. Okay na? Okay na? So reciprocal this n plus 1 factorial is n plus 1 factorial is n plus 1 factorial by 3 greater than or equal to 0.1 amma. By 3 greater than or equal to 0.1. For what value of n it will be? For what value of n it will be? N equal to 0 పెట్టానుకో, 0 by n equal to 0 పెట్టానుకో, ఇక్కడ రాస్తాను నెక్స్ట్ స్లైడ్ లో. n plus 1 factorial by 3 is greater than or equal to 0. n equal to 0 పెడితే 1 factorial by 3 is 0.3 is not greater than or equal to, sorry, greater than or equal to నే కదా అది కూడా. సో
1 by 0.1 కదా సార్?
యా అదే అమ్మా, ఏదో రాంగ్ చేశాను చూస్తాను. వెరీ గుడ్. 1 by 0.1 అవునా? 1 by 0.1 అంటే 1 by 0.1 అంటే 10, రైట్? n plus 1 factorial by 3 is greater than or equal to 1 by 0.1. 1 by 0.1 అంటే 10, రైట్? సో n plus 1 factorial by 3 10 ఎప్పుడు అవుతుంది? సాల్వ్ చేస్తానంటే చేయండి, లేదా డైరెక్ట్ చేస్తానన్నా చేయండి. సో n plus 1 factorial by is greater than or equal to 30. సో n plus 1 factorial greater than or equal to 30 ఎప్పుడు ఉంటుందమ్మా? n equal to 4 అయితేనా? 4 అయితే ఎంత వస్తుంది? 3 అయితే ఏమవుతుంది? n equal to 3 is nothing but 4 factorial. 4 factorial nothing but 24, not 4 పెడితే 5 factorial is greater than or equal to 30. So at least 4 terms required. At least 4 terms required. The remainder will be within 0.1. Within 0.1. Okay, now likewise we have to find the remainder estimation. Likewise we have to find the remainder estimation. Yes, Ivina. So using the, write down next column, using the fifth degree Taylor series, fifth order Taylor series for sin x for f of x equal to sin x, centered at a equal to 0, centered at a equal to 0 to estimate sin x, to estimate sin x. How large can x to be get? How large can x be to get an estimate within 0.005. The estimate within 0.005. Okay, na? Right? So fifth order Taylor's polynomial. For fifth order Taylor's polynomial, what is the remainder? Anyone? What is the remainder? Anyone? M by n plus 1 factorial to mod x minus a whole power n plus 1. So that is 6, 5 plus 1, 6. So what is m? F power 6 of x less than or equal to m. Okay, na? F power 6 of m is less than or equal to m. So f of x is sin x, f dash of x is cos x, f double dash of x is minus sin x, f triple dash of x is minus cos x, f fourth dash of x is sin x, f fifth dash of x is cos x, f sixth dash of x is minus sin x, So modulus of f sixth dash of x is what? Modulus of minus sin x. Modulus of sin x is mod sin x. Mod sin x, what is the greatest value of mod? What is the greatest value of mod sin x? The greatest value of mod sin x is 1, right? Therefore, m equal to 1. Okay, na? M equal to 1. Okay, na? So therefore, Rn of x I can write like this. Rn of x. So 1 by Rn of x is 1 by 6 factorial into mod x minus 0 whole power 6. So మనం ఏం చేయాలి? Nothing but mod x power 6 by 6 factorial. So మనం ఏం చేయాలి? How large n will be taken? So that how large can x to be taken so that within 0.05. 0.005. Okay. So mod x power 6 by 6 factorial is less than or equal to 0.005. How much this value? Anyone? 0.005 into 6 factorial. Anyone? $3.6 I get. $3.6 I get. Okay, now. Which is nothing but minus 3.6 less than x power 6 less than 3.6. Nothing but minus 3.6 whole power 1 by 6 less than x less than 3.6 whole power 1 by 6. Whole power 1 by 6 enta 1.2379 minus 1.2379 to x less than 1.237. So the largest, what they are asking, how large can, right? How large can, the largest x will be 1.2379. అర్థమైందా అర్థమైందమ్మా ఎలా చేశాను? ఏమో సార్ ఏదో ఒకటి చేశారు, నాకెందుకు ఈ బాధలు. అంతేనా? రాసుకున్నారా? ఎనీ డౌట్స్ ప్లీజ్? Any doubts, please? So likewise, we have to estimate using the remainder. Okay, the number of terms అడుగుతారమ్మా ఒక్కోసారి. The number of terms we can estimate, and how large x also some we can estimate. Okay na? రాసుకున్నారా? Next we go for the Taylor series by substitution. The Taylor series by substitution. So the Taylor series by substitution. Okay na? Suppose the Taylor series of cos of root of x plus 4 కావాలనుకోండి. The Taylor series of cos of root of x plus 4. Okay na? Cos of root of x plus 4 కావాలనుకోండి. ఏం చేస్తాం? సో నేనేం చేస్తానంటే the Taylor series of cos x కనుక్కుంటానమ్మా. cos x at x equal to 0. ఇక్కడ x ప్లస్ లో నేనేం చేస్తానంటే రూట్ x plus 4 ని సబ్స్టిట్యూట్ చేస్తాను. ఓకేనా? సో f of x equal to cos x equal to 0. f of 0 cos 0 1. f dash of x minus sin x. f dash of 0 f double dash of x minus cos x. f double dash of 0 minus f triple dash of x minus sin x. f triple dash of 0 f fourth dash of x minus cos x. Plus kada plus f fourth dash of 0 1. Okay na? So therefore the Taylor series of f of x equal to cos x at x equal to 0 is f of x equal to f of 0 1, f dash of 0 0, f dash of 0 0, f double dash of 0 minus 1 by 2 factorial into x square, f triple dash of 0 0, f fourth dash is 1 by 4 factorial x power 4 and so on. Nothing but cos x equal to 1 minus x square by 2 factorial plus x power 4 by 4 factorial plus and so on. So this is the Taylor series of cos x. I want cos of root of x plus 4. Cos of root of x plus 4. Root of x plus 4 whole square by 2 factorial. Root of x plus 4 whole square whole power 4 by 4 factorial and so on. Because of two derivative of this, it's somewhat taking time. It's derivative of this taking somewhat time, but it is easy to write from here. It is easy to write from here. Okay, now any doubts? So same way like Taylor series by multiplication, Taylor series by multiplication. Taylor series by multiplication ante suppose I know the Taylor series of cos x. If you want Taylor series of x cos x, x square cos x by x, cos x by x square, cos x by x power 5. Okay. So these things if you want, if you know Taylor series of cos x. So x cos x ante whole thing multiply with x. Okay. Cos x by x ante cos x by x square ante 1 by x square of this. Likewise, whatever you required, multiplying, dividing, okay, all thing you go by ln x by x, okay na. ఇలాంటివన్నీ మనం ఈజీగా ఓకే e power x by x square ఇవన్నీ కూడా మనం ఈజీగా మల్టిప్లై చేసి చేసుకోవచ్చు, మల్టిప్లై ఆర్ డివైడ్. ఓకే, సో likewise you can find the Taylor series by multiplication or by substitution. Okay na. Any doubts please? Any doubts please? Are you getting my voice? So likewise, the Taylor series by
Yes, sir.
substitution by multiplication you will get easily. Okay. So thank you all. So that's about today's class. We'll meet our next class.